You ever wonder how your GPS just knows the fastest route? Or how enemies in a video game seem to navigate these super complex worlds so intelligently? Well, a lot of the time, the secret sauce is this really elegant algorithm called A-star search. So today, we're going to pull back the curtain and see exactly how it works.
So here's the big question, right? How does an AI find not just any path, but the absolute best one, the optimal path, from point A to point B without wasting time checking every single possible turn? I mean, that would take forever. This is the core challenge of pathfinding, and it's the exact problem A-star was built to solve.
All right, to really get a handle on the solution, we've got to frame the problem first. So let's imagine we're on a road trip. We're in Romania, and our whole goal is to get from the city of Arad to Bucharest. But we don't just want to get there, we want to find the guaranteed shortest route.
Now, for an AI to solve this, we can't just tell it to get to Bucharest. We need to speak its language. We have to define the problem. So the initial state is simple. We're in Arad. The actions are the different roads we can take. The transition model just tells the AI what happens when it takes an action. Drive from Arad to Sibiu, and surprise, you're in Sibiu. The goal test is that constant question, are we in Bucharest yet? And finally, the path cost. Well, that's just the total distance we've driven so far.
Okay, so putting it all together for our little road trip, the quest is crystal clear. We need to find the optimal route. And that word, optimal, is so important here. It doesn't mean a pretty good route or one that's just kind of fast. It means the guaranteed, mathematically proven, absolute shortest path, no exceptions.
So before we get to the genius of A-star, let's look at a couple of other strategies. Think of them as two different types of travelers. One is super cautious, and the other one is, well, a little too greedy for its own good. And as we'll see, both have some pretty big flaws. On one hand, you've got the cautious traveler. This strategy only cares about the path it's already taken, what we call G of n. It expands its search outward in perfect circles, so it will find the best path eventually, but man is it slow. It has no sense of direction. Then you have the greedy traveler. This one only looks forward. It uses a guess, a heuristic we call h of n, to estimate how far the goal is. It always picks the road that looks like a shortcut. It's fast for sure, but it's reckless and can easily get tricked into taking a much longer route overall. And this really gets to the heart of what we mean by intelligence in AI. You see, an intelligent agent is supposed to take the best possible action. Neither of our travelers is really doing that. The cautious one is too slow and the greedy one is too reckless. We need something better. We need a strategy that's both smart and efficient.
And this is where A-search makes its grand entrance. It's not just another strategy. It's a beautiful, brilliant combination that takes the best parts of our two flawed travelers and puts them together into one perfect balanced approach.
The magic is all in this one simple formula. F of n equals G of n plus H of n. So what does that mean? Well, A-star decides where to go next by adding two numbers together. First, G of n. That's the actual distance we've already traveled to get to a city. That's the wisdom from our cautious traveler. Then it adds H of n, the estimated distance from that city to the finish line. That's the foresight from our greedy traveler. The total, F of n, is the best guess for the total trip cost if we go through that city.
Okay, let's see it in action. We start in Arad, and we have two choices. Go to Sibiu or go to Timisoara. For Sibiu, we calculate its F value. We take the actual road cost from Arad, and we add the straight line as the crow flies distance to Bucharest. Then we do the exact same calculation for Timisoara. Whichever city has the lower total F value, that's where A-star explores next. It's making a smart, informed choice at every single intersection.
And that's the genius of it, right there. It's this perfect balance. AI isn't just looking backwards at the road already traveled, or just staring blindly ahead at the horizon. It's the only traveler smart enough to do both at the same time. It's constantly weighing what it's already invested against a very smart guess about the future.
Okay, but how can we be so confident that A-star will always find the best path? Not just a good path, but the perfect one. Well, the algorithm has a secret weapon, a single, simple rule that gives it this incredible guarantee.
The secret is a concept called an admissible heuristic. Now that sounds complicated, but it's actually super simple. All it means is that our guess about the remaining distance, our h of n, can never be an overestimation. It can't be longer than the real, actual shortest path. A perfect example is the straight line distance, right? You can't get any shorter than a straight line, so any real road is going to be that long or longer.
Let's put that another way, because this is the key. The guess, h of n, is allowed to be optimistic. It can totally guess a distance that's shorter than the real path, but it can never be pessimistic. It can't ever say, I think it's 300 miles away, if the real shortest path is only 250. As long as we stick to that one simple rule, A* is guaranteed to be perfect.
And hey, don't just take my word for it. Our source material says it right here, plain as day. If that heuristic, h of n, is admissible, if it never overestimates, then A* is optimal. Full stop. It will find the shortest path every single time. That's what makes it so incredibly powerful.
So yeah, A* is amazing for finding routes on a map, but its true impact, the reason we're even talking about it, is that this exact same logic can be applied to a huge range of problems that have nothing to do with geography.
Honestly, once you start looking, you see its logic everywhere. In video games, it's how that monster finds the smartest path to get to you. In computer networking, it helps route data packets across the internet. It can solve complex logic puzzles, help computers understand sentence structure, and even help in bioinformatics. And for really massive problems, there are even special versions like Ida* that can handle things with limited memory. A* really is one of the cornerstones of modern AI.
So A* search gives an AI this incredible power to find the best path through a world that it completely understands. But that just leads to an even more fascinating question, doesn't it? What happens when the agent doesn't have the map? How does an AI find its way and make a plan when the world is full of unknowns? Well, that is a whole other adventure.